Okay, hello everyone. I welcomes to all with a new lecture, that is behavior of electric dipole in an electric field. This is another lecture belongs to lecture series of electricity magnetism. So let's start. Here you can see that a dipole, that means two opposite charges plus and minus separated by a distance 2a, is placed in a uniform electric field E. Here the direction of electric field along your positive y-axis direction and the direction of electric dipole moment along positive x-axis direction as shown in the figure. Same thing it has been written that consider these things you have to write in your note. Consider an electric dipole P is placed along positive x-axis in a uniform electric field where E is directed along positive y-axis as shown in figure. In this situation, two charges plus q and minus q will be experienced by two forces. So, if this way, if along positive y-axis E vector will be directed, then on this positive charge, a force will be executed along this direction, that will be plus QE, and another force will be experienced on this minus q, that will be minus QE along negative y-axis direction. Same thing it has been written, experienced by two forces, this and this. These two forces act on two different lines. As the result, a torque, that is your tau, will be experienced on the dipole. So here you can see that this force acts along this line, okay, and this force acts along this line. So two forces acts on two different lines, and in this situation the separation between the two charges is your 2a. If it is so, a torque will be executed on the dipole and the dipole will start to rotate about the point O along this direction. Right. So let us consider a instantaneous position of the electric dipole moment. That means when if will be rotated along this direction, suppose this is the instantaneous position, and at this position the dipole moment direction will be along this direction, and let us theta will be the angle between the electric field and dipole moment for this situation. Okay, we know that the magnitude of the torque tau is nothing but magnitude of either force into perpendicular distance between the lines of action, between the lines of action. So here this one and this one, two lines of action, right? Now magnitude of either force, if we want to try to find out the magnitude of the tau or torque, magnitude of either force we need, magnitude of either force is your QE. Okay, here it has been written QE. The perpendicular distance between the lines of action, here lines means this line and this line. For this situation, this distance, or we can say this distance, is the perpendicular distance between the two lines of action. So for that, what we have to do, we have to draw this line parallel with y-axis, and another this line parallel with x-axis. Both are going to be meet at point M. Okay, if this angle is theta, so if they are meet at point M perpendicularly, okay, and if this angle is theta, this angle also will be theta. So in the triangle A, M and B, you can see that this is your 90-degree angle, okay, and this is your theta. So obviously this distance, which is the so called perpendicular distance between the line of action, is your 2a sin theta. Okay, so if it is theta and this is the 90-degree, and this distance, this B to A is your 2a, So obviously this distance will be 2a sin theta. Okay, so this distance will be 2a sin theta. So perpendicular distance between the line of action will be 2a sin theta. Now this can be rewritten as q into 2a e sin theta, and we know that q into 2a, either charge, magnitude, and distance between them is nothing but magnitude of dipole moment into e sin theta. So here P into E sin theta, we found torque magnitude. Okay. Now the vector form of this torque will be P cross E. Why P cross E? We know that in general torque is nothing but R cross F, either force and the so called perpendicular distance. So here you can see this is the distance, or this is belongs to your distance. Okay, so only for that P cross E we have to consider here tau. The tau in vector form will be P cross E. So what is the direction of the tau? We are going to consider Fleming's left hand rule. Along this direction we have been considered as your electric field. Along this direction is your dipole moment, suppose. So this will be represent the torque direction. So if we are going to consider the initial position, suppose this is your initial position, this initial position means dipole moment along exactly positive x axis direction along this way, and electric field intensity along positive y axis direction. So the tau will be along this direction, that means along outward of this screen, that means positive along the positive z axis direction. So here we found the direction of tau will be along positive z axis direction. Now from this expression we can found the maximum and minimum value of the torque. If theta will be equal to 90 degree, then we can found the maximum value, because sin theta will be 1, and if theta will be 0, then we can get the minimum value of the torque. That means when the dipole moment will be along the positive x axis direction, this angle will be theta, this angle will be theta, this angle, this theta will be 90 degree, this theta will be 90 degree. That means for this situation, when the dipole moment will be along x axis, the maximum torque is going to be executed on this dipole, and when this dipole will be rotated along the electric field intensity, the torque will be minimum. Okay, so this is all about this topic. Now next class we are going to discuss about potential energy of an electric dipole in an electric field. Okay, so if you feel that this content or this video is helps you somewhat, then like and subscribe. Thank you so much for watching this video. Thank you.